Heading right, magnetism. Magnetism. Now, what are magnet and why there is something called as magnetism? Long ago in Magnesia, one shepherd took the cattle for grazing. When the cattle were grazing, he had a stake with iron attached at the one end. So when the cattle were grazing, he was rotating this rod. It got stuck to a stone. जैसे स्टोन को चिपक गया, उसको लगा उधर कुछ तो सुपरस्टिशियस पावर है which is pulling his stick. He went running in the village. Fortunately उधर एक साइंटिस्ट था. The shepherd, he told the scientist all this situation. Scientist said, don't worry, come, I will check what is there. The scientist found that that stone was iron ore. नाम था इसका मैग्नेटाइट, also called as lodestone. He said this iron ore, which is magnetite Fe2O3, had the power of attracting iron particle. Scientist told, I will give my name to this property of iron ore to attract the iron. I will call it as scientism. Shepherd says, no, you call shepherdism. फिर दोनों में आर्ग्यूमेंट हो गया, बोला ना तेरा ना मेरा. मैग्नेटाइट का ये टी will remove and put magnetism. So property of iron ore to attract iron particle is called as actually magnetism. Again I'm repeating, what is magnetism? Property of iron ore, that is magnetite, to attract the iron particle is called as magnetism. This is natural magnet, but natural magnet will not have definite shape, वो कुछ भी shape का मिलेगा. So to have use of magnetism for day-to-day purpose, different types of magnet were constructed. A magnet in the shape of brick is called as bar magnet, and magnet in the form of horseshoe, this U-like structure, is called horseshoe magnet. So generally we use either bar magnet or horseshoe magnet, or in industries, magnet created by passing current through the coil bounded on iron ore. These are few magnets which we have to study in 11th and 12th. Again, see what is magnetism. What is magnetism? The property of iron ore, that is magnetite, to attract the iron particles is called as magnetism. Right. First line, magnetism. The property of iron ore, that is magnetite, to attract iron particles is called as magnetism. There are different shapes of magnet, such as bar magnet, comma, horseshoe magnet. Completed?
sir.
See, when we suspend a bar magnet in air, it is found that it remains in one particular direction. Do you know the direction? When you tie with thread, हवे में लटकाया तो किधर रहने वाला है ये? North south?
North side.
Outside.
This property is called as directive property of the magnet. It remains in north south direction. So Earth is also a giant magnet. Earth's magnetism will deal later on. First artificial magnet here. Earth's magnet north pole is at geographical south pole, and Earth's magnet south pole is geographical north pole. So if we suspend a bar magnet, then north is attracted towards south and south is attracted toward north of a magnet. So magnet remains in north south direction of Earth, which is called directive property. When iron particles are brought closer, it gets attracted. This is called attractive property. So every magnet will show two properties, directive property and attractive property. Now if this is magnet, the corner facing to the north is called north pole. The one which is facing to the south is called south pole. This way we have how many poles? One or two? How many poles are there?
Two.
Two.
Two. असली में नहीं है, ये assumption है. नॉर्थ को फेस किया तो नॉर्थ पोल बोलो, साउथ को किया तो साउथ पोल बोलो. तो असली में नहीं को हम लोग बोलते हैं इमेजिनरी, मतलब ऐसे ही फेंका है, उसको बोलते हैं fictitious. So magnet consists of two fictitious poles, south and north. If I cut this into two parts, then can I separate south and north individually? इसको बीच में कट कर दिया तो ये पूरा साउथ ये पूरा नॉर्थ ऐसा अलग कर सकते हैं क्या?
No, sir.
नहीं.
No,
sir.
फिर से ऑटोमेटिकली एक साइड साउथ एक साइड नॉर्थ होएगा. मतलब सिंगल पोल जैसा चार्ज होता है कैनॉट एग्जिस्ट, वो हमेशा डाइपोल में रहेगा जैसा इलेक्ट्रिक पोल. तो magnetic pole cannot be isolated or cannot be separated. They will be always in the form of pair south north, right? Dipole. Two fictitious poles separated by finite distance is called as dipole. The property of dipole to align itself in north south direction is called as directive property. The property of dipole to attract ion particles is called as attractive property. So there are two uses depending upon direction and attraction. Direction वाला Mariner's compass भी use होता है. Attraction properties are used for many other purposes. So write this dipole definition and 2 points write down properly. That okay. So isolated pole does not exist. Then magnetic length. So if this is dipole, end to end length is called geometric length, and pole which is slightly inside, pole to pole distance is called magnetic length, denoted by 2L. So I can say the finite distance between two fictitious poles is called as magnetic length. The finite distance between two fictitious poles is called magnetic length. It is denoted by 2L. Right.
Done, sir.
Next. Magnetic length is denoted by 2L. Then note, write down geometric length equals to geometric length equals to 6 upon 5 times magnetic length. Axis of dipole. Axis is line. So line joining south pole and north pole of dipole is called axis of dipole. The same way we did in electric dipole. A line joining south pole and north pole of dipole is called as axis of dipole. Then write equator of dipole. A line passing through the center of dipole and perpendicular to the axis of dipole is called as equator of dipole.
Done, sir.
Okay. Next is very important definition. Usually this they ask for 2 marks. Dipole moment. Dipole moment. The product of magnetic length, which is denoted by 2L, and pole strength. Every magnet's pole has got some strength. It is denoted by letter M, small m. So product of magnetic length and pole strength is called as dipole moment. It is given by capital M equals to 2Lm. Its SI unit is ampere meter square. It is a vector quantity directed from south pole to north pole. Like we had electric dipole moment from negative charge to positive charge. This is directed from south pole to north pole. Right definition of dipole moment. Done?
Sir,
Yes.
so how come the SI unit is ampere? Don't get that.
Few things you will come to know once we deal with the chapter, because even current carrying moving charge means current, na?
So yes.
So whenever there is current, there is always magnetic field produced,
Yes, sir.
and that magnetic field has got south pole. Any magnet will have south pole, north pole,
Yeah.
which has got dipole moment, and we will derive it as formula number of turns into current into area. So current is ampere, area is meter square. Because of that, it is called ampere meter square. Okay.
Okay, sir. Thank you.
Then
Done, sir.
Based on this, we are having few MCQs or numerical. See, this is a bar magnet having length L, dipole moment M, bent in the form of semicircular arc. Find what is new dipole moment. Can you tell what is magnetic length in the first case? L, na? L. So dipole moment will be L M. I have not taken 2L. L M. Now for the steel bar bent in the form of arc, now magnetic length is not this boundary. This is not the magnetic length. What is magnetic length? Distance between south pole and north pole. So if this is R, this is R, what is new magnetic length?
2R.
2R, correct. New magnetic length equals to 2R. So first dipole moment is L into M pole strength. Second dipole moment M dash is 2R into M. So M dash upon M equals to 2R M upon LM. MM cancel. M dash upon M equals to 2R into length. What is this length L in terms of R? Can I say half of circumference? Yes, can I say? This boundary is nothing but in terms of R half of circumference.
Yes, sir.
So this gets cancelled. Therefore, M dash equals to M upon pi. So when a bar magnet is bent in the form of semicircular arc, new dipole moment is M upon pi. Frequently asked question. Either they can say show that, or they can give four option and select the correct option. Please solve this.
It should be 2M by pi, right?
Yes, sir.
Pardon?
2M
2M,
by
2M, yes, 2M, 2M. Sorry, sorry, 2M, 2M by pi.
Then
Second one, a bar magnet of length L Dipole moment capital M is bent in the form of arc with subtends angle 60 degree at the center. Find new dipole moment. Again, same concept. Find new dipole moment. New original dipole moment is L into pole strength M. Now, if this is south pole, this is north pole. Can you tell me what is dipole moment? Sorry, what is magnetic length? What will be new magnetic length? See, magnetic length is always direct distance between south pole and north pole. So by the geometry, can you tell what will be this distance? This becomes isosceles triangle. These two are equal and one angle 60. So is it equilateral triangle OSN?
Yes, sir.
So new dipole moment is radius, na? Correct?
Yes, sir.
If I get R in terms of L, I can solve. Since length of arc is radius into angle. Now length of arc is nothing but this length L, radius R, angle is 60 degree, which is pi by 3. So R becomes 3L upon pi. Now new dipole moment is R into M, which is equals to 3L upon pi into M equation 2, dividing 1 by 2, we get M dash upon M equals to 3L upon pi M divided by Lm. Lm cancel. M dash equals to 3M upon pi. I hope you followed. Yes, everybody has followed this.
Yes.
Okay, please solve. This was asked in both JEE also once and even in NEET once. And 2M upon pi वाला पूछा था CET में.
Done, sir.
Okay. this one, see, a bar magnet of length L, dipole moment capital M, is bent at the center at right angle. Find new dipole moment. Find new dipole moment. Again, if this is south pole, this is north pole, this will be south, this will be north. This direct distance is called dipole moment. Can you tell me what will be the vertical distance? OS?
R,
Half of L, correct? This is also half of L. So what will be this new dipole moment?
root of L by 2 square plus L.
Very good. New dipole moment, new magnetic length. I'm doing by shortcut method. New magnetic length. It is like two vectors perpendicular. Result is root 2 times given vector. So root 2 L by 2, that will become L upon root 2. Now M equals to L into small m, and M dash will be L upon root 2 into small m. Therefore, dividing 2 by 1, we get M dash upon m is L upon root 2m divided by Lm. Lm cancel. So M dash equals to m upon root 2. Okay. Hello.
Yes, sir.
Oh, sorry. मैसेज देखा पहुंचता है ड्रीम स्मॉल में आग लग गया है और उधर ही है सनशाइन हॉस्पिटल तो वो पूरा रास्ता ब्लॉक कर दिया है मतलब भांडुप से जा नहीं सकते पता नहीं प्रसाद को कैसे करे
Done, sir.
Okay. So for dipole moment, you got idea how to get dipole moment when same bar magnet is given different shape. This is one bar magnet. I'm drawing three bar magnet. You have to find resultant dipole moment. One, two, three. So three bar magnets are joined as shown: south pole, north pole, south pole, north pole, south pole, north pole. Three identical bar magnets of dipole moment capital M are joined together. Find resultant dipole moment. Find resultant dipole moment. See how to do. First bar magnet, second bar magnet, third bar magnet, all are identical, having same dipole moment. Find resultant dipole moment. Dipole moment is a scalar or vector. If it is vector, then what is its direction? From where to where? Already we wrote
South to north.
south to north. Okay. So for first bar magnet, this will be dipole moment, south to north. Correct?
Yes, sir.
South to north. One dipole moment, M. M1 is M. And second bar magnet's dipole moment will be in which direction? Again south to north.
Yes, sir.
So it will be this way, south to north. South to north. Again M2 is also M. And third bar magnet, again identical, so same magnitude of dipole moment. Direction is from south to north. This is M3 equal to M. I want its resultant. Can anybody tell by vector what will be resultant?
All are in the same direction.
Pardon?
All are in the same directions.
No, all are not in same direction. All are forming closed loop. Same direction means they are all following clockwise. South, north, south, north, south, north.
Yes, sir.
So what will be resultant? Now those who have done vector properly, they know. When all the vectors are taken in order, then resultant vector drawn, the last vector drawn from start of first, end of second is resultant. Na? End of last is resultant. Okay. Can anybody tell? एक वेक्टर ये एक वेक्टर ये फाइनल क्लोज हो गया तो रिजल्ट क्या रहता है जीरो है ना बिकॉज देर इज नो डिस्टेंस बिटवीन फर्स्ट एंड लास्ट का स्टार्ट एंड एंड इसको बोलते हैं रिजल्टेंट ना पॉलीगॉन लॉ ऑफ वेक्टर एडिशन याद आया क्या आपको when
Yes.
n number of vectors are represented by sides of incomplete polygon, then last vector drawn from start to the end is called as resultant. Are you remembering this?
Yes, sir.
Yes.
Can I say therefore resultant is zero? Can I or not? नहीं समझा रिजल्टेंट जीरो
Got, sir.
देखो ये एक वेक्टर ट्राइंगल लॉ लिया तो ये रिजल्ट हो गया ना ये दोनों का 1 and 2 का रिजल्ट ये हो गया ना ऐसा बाय ट्राइंगल लॉ
Yes.
और दूसरा एक इधर ऑलरेडी है so these two are equal opposite what will be my resultant zero or not तो
Yes.
इक्विलेटरल ट्रायंगल बन गया ना सब साइड से इक्वल तो ये m दोनों का रिजल्ट भी m नाउ ये m और ये भी m लेकिन उल्टा तो वैसे भी समझ गया रिजल्ट जीरो किसको किसको नहीं समझा है यस आदित्य अवान आदित्य यू ऑल फॉलोड ईशा नेहा प्रांजलि
Yes, sir.
Yes. Yes.
just write properly this was asked in exam chapter is very simple but to make it difficult ऐसा complication कर देते हैं वो लोग done shall I clear
Yes.
next question two identical bar magnets south pole north pole south pole north pole are joined together angle between them is 60 degrees find resultant dipole moment one dipole moment south to north m other dipole moment south to north m so it is like two vectors p is m q is m angle between them is 60-degree find resultant so resultant dipole moment by parallelogram law is m square plus m square plus 2mm cos of 60 degree 2m square plus 2m square cos 60 is half you can cancel this 2 so it is nothing but root of 3m square equals to root 3m okay clear this also hello
Yes.
fine Done?
Yes.
Now I'm drawing the dipole. I want answer from you instantaneously. Those who have attended vector from start, I want answer from them instantaneously. Yes. Identical dipoles find resultant dipole moment. बोलो
Two
direct.
times.
Pardon? कितना? Yes, somebody said something. कितना?
2-3 times.
No. यही तो मार खा गए ना आप. This is one dipole moment M, south to north, and this one is another dipole moment south to north. Angle between these two vectors, is it 60? It is 120, na?
120.
So what will be resultant? Two vectors are equal and inclined by 120. Result is same as given vector.
So same.
Yes. So answer is that. Copy. Common mistake every student does. He writes root 3f. Done?
Yes.
So we have completed what is meaning of magnetism. Then dipole, directive property and attractive property, magnetic length, geometric length, axis, equator, dipole moment, and few numericals. Next heading, right? Magnetic field. Magnetic field. What is electric field? The space surrounding charge within which unit positive charge placed experiences force is called as electric field. So what magnetic field will be? The space surrounding a dipole. Dipole means magnet. The space surrounding a dipole in which, or we can say magnet to make it easier, otherwise you will get confused. The space surrounding a magnet in which another magnet placed experiences force is called as magnetic field. It is denoted by B bar. Right. Okay. Completed?
Yes, sir, done.
Next point. Properties of magnetic lines of force. Like we have electrical lines of force, we have got magnetic lines of force. Electric lines of force starts from where? From which charge?
Positive to negative.
Positive. Positive and terminate in negative. It doesn't return back. But if this is bar magnet, then magnetic line starts from north pole, enters in south pole, outside the magnet. Within the magnet, it is from south to north. So it is closed curve. This point you have to remember. So magnetic lines of force starts from, start means originate from north pole and travels towards south pole outside the magnet. So north to south outside the magnet and south pole to north pole inside the magnet. Second, it forms closed curve. Write this 2 point. Can I clear this?
Yes, sir.
Third point, means it is actually identical or analogous to your electric lines of force only. How to find direction of electric field? By drawing tangent. So here also same, the direction of magnetic field at any point is found by drawing tangent to the magnetic lines of force at that point. Magnetic lines of force at that point. Fourth, they do not intersect. If they intersect, then we have two directions of field which is not possible. Fourth point over. Copy third and fourth. Written? Okay. One more point. Okay. The number of lines of force crossing, number of lines of force crossing per unit area decides the magnitude of the magnetic field B bar. More lines of force, it is stronger. Less, than it is weak. Copy. Written?
Yes.
Then write magnetic flux. Magnetic flux. The number, same as electric flux, the number of lines of force perpendicular, just write number of lines of force is called magnetic flux. It is denoted by, इसको phi बोलते हैं, phi, phi, phi. Its SI unit is Weber. वेफर नहीं है, वेबर है, वेबर, WB साइंटिस्ट का नाम, जस्टिस वेबर नहीं, ये वेबर. एक जस्टिन वेबर भी है ना, सिंगर. नेक्स्ट लाइन. दिस इज लास्ट फॉर टुडे. द मैग्नीट्यूड ऑफ मैग्नेटिक फील्ड strength. The magnitude of magnetic field strength denoted by B at a point in magnetic field. Magnitude of magnetic field at a point in magnetic field is given by magnetic field, okay, B equals to magnetic flux upon area, is given by magnetic flux upon area. Therefore, B equals to phi upon A. Therefore, B equals to flux phi upon area A. Its SI unit is Weber per meter square or Tesla. Tesla? What is
Tesla.
Tesla? Have you heard about name Tesla?
Nikola Tesla.
एक industry है in US, Tesla. Who is owner of Tesla?
Elon Musk.
Who?
Elon Musk.
हाँ, Musk, बराबर. So SI unit is Weber per meter square or Tesla. One Tesla is also called as 10 raised to 4 Gauss. आज के लिए इतना. Study and keep this much. Very simple chapter we are doing. In 2 more lectures, this chapter will get completely completed. Sunday's test you are knowing it is electrostatic only MCQs. थोड़ा पेपर ट्रिकी होएगा because you know a lot, so I want to extract how much you know. So tomorrow again, can we have extra class for electrostatics revision? Revision with